All right. As I was saying, my name is Edward Arvia. I work for a company called DataSoil. And to give you a little bit of background about me, like most of you, I've been working with Microsoft products for quite a while. Started off as a developer, VB6 and SQL Server 7. Spent a couple of years as a Microsoft certified trainer. Spent a couple of years in Reading as a SQL Server Premier Field Engineer. And right now, today, I'm a contractor pretty much cleaning data toilets for anybody who pays me money to do that. The reason I'm doing this talk, just to kind of set the expectation, is 9 months, 10 months ago, I kind of stumbled across this whole concept of big data, and I thought this is probably something I need to get into. So right back then, I had really no Linux experience and no big data experience. So the chat is pretty much how I've, over the last couple of months, got myself to a point where I feel comfortable to work with big data, and hopefully by sharing this, it'll help a few of you trying to do the same. Our agenda for today is going to be very straightforward. We're going to talk about what exactly is big data, what are the big differences in the philosophy of development between what we're currently using in our SQL Server environment versus the big data environment. We're going to talk a little bit about how I can get into big data, some of the tools, some of the inspirations, the future of big data, what people are currently using big data for, and what are some of the advantages potentially of using it for future solutions, summary, conclusion, and then obviously the Q&A at the end. Now, when it comes to what exactly is big data, we're going to talk a little bit about the origin of big data, the technology and the terminology that you should be aware of, as well as some of the big players that you might want to have a look at. Now, typically, like any good superhero or mutant, so to speak, we need a good origin story, and big data has quite an interesting one. This is probably going to be a little bit small, so I'll read it off. In 2002, two gentlemen named Doug Cutting and Mike Caffarella started working on a search engine called Nutch, which is basically roughly based around Lucene and working on Java. In 2003, the smart people at Google decided to publish a paper on how they actually use big data, how they use data in their search environment and how they deal with distributed data across multiple nodes. In this case, talking about the GFS, or the Google File System, and the concept of MapReduce. 2004, Cutting decides to add DFS and MapReduce support to his engine that he's building for Nutch. 2005, absolutely nothing happened. It was very, very quiet here. Not 100% true. I do believe a groundbreaking relational database was released in 2005 that changed the way we physically view data. You should know it as SQL Server 2005, but unfortunately, it has nothing to do with big data, so it didn't make the slide. 2006, Yahoo decides to hire Cutting, and basically Hadoop spins off the Nudge project, and is aptly named after Cuddy's son's toy elephant. So if you wondered where all the elephants are coming from, Hadoop was basically Cuddy's son's toy elephant. It sounded a little bit ominous. 2007, people start using big data in quite a bit more. The New York Times decides to take 4 terabytes of archives and run it through a couple of nodes on the Amazon cluster. 2008, it becomes a lot more mainstream. Companies like Yahoo, Last.fm, Facebook, these guys are all starting to jump into big data to take care of their big number crunching. And then 2009, this is where the guys start setting records. In this case, in 2009 in April, Yahoo did a terabyte sort in 3.5 minutes over 910 nodes. They cut that down to 62 seconds over 1,460 nodes. And then finally did a petabyte sort in 60.25 hours over 3,658 nodes. Personally, I don't have that many nodes lying around at home to try and do some of these things myself, but it's quite impressive. And I think it kind of sets the tone for when we're going to talk about big data. Big data doesn't need to be big per se, because we can run big data algorithms on small groups of data as well. I think where it comes into its own is where you start talking about doing these types of calculations, where thinking about putting that into a relational database kind of makes your head hurt a little bit. However, the one we're really keen about is in October of 2009, Yahoo decides to take all their production open code for Hadoop and open source it. And since then, it has been an Apache top-level project. Personally, I thought Apache were the guys that made the web servers, but apparently they do quite a bit more. For those of you who haven't been to the Apache website, they've been around since 1999, and they've actually helped quite a few big projects come from basically development through to where we're actually currently using it in the enterprise environment. The web server obviously is one of them. Hadoop is another one, and you'll see that a lot of the technologies we're going to be talking about later in the slides, most of these came through the Apache incubator and actually became top-level Apache projects. So good to know. The next part is the technology and the terminology that we need to be aware of. Talk a little bit about the components or the core components of Hadoop, and we're going to talk about some of the things that we need to know about that might be interesting for us to use. First of all, a couple of common components. We're not going to spend much time on them. They're kind of the components that just make all the different Hadoop elements talk together. The one we do want to talk about is the HDFS, or the Hadoop file system. Now, the Hadoop file system typically is a distributed file system specifically designed for high throughput and computation of data. So if we think about it, if I have a Hadoop cluster and I give it a file and say, please go and store that file for me, Hadoop says, fair enough, I'm going to take this and I'm going to break it into a set of data blocks. Once I've broken your file up into data blocks, I'm going to make 3 copies of each one of these blocks. And I'm going to go and I'm going to store these 3 copies of each of the blocks across my node of servers, in which case it gives me my data redundancy. So if I'm running a query on this particular data, and I lose 1 server, I lose 2 servers, my resource negotiator will figure out what's gone wrong. It'll simply point my query to where the data actually still exists, and then hopefully make quick copies, so in case I lose any more servers, again, I have a copy of the information that I can work with. Now, we said before, when we spoke about what Google did with what they planned and then how Cutty introduced into his particular Nutch engine, the first was the file system. The second part was the concept of MapReduce. Now, MapReduce in this case is the Java code that basically goes and does all the hard number crunching on your behalf. The typical word count example that's always been used, if I have a document of potential words and I want to go and I want to get the word count for these, I send that through and say, go and get me the word count for all the words in this particular document. What Hadoop does, it goes and it splits it up to the mappers. The mappers go and count the words, splits it through to the reducers aggregate the word count, and it leaves me with my result at the end, which in this case is how many of each word I have in my particular document. Now, the number of mappers and the number of reducers are customizable. If you don't customize it, it'll simply just run on the resources you have available. Right, so currently we're in MapReduce version 2. MapReduce version 2 is a yarn-based system that specializes in parallel processing of big data, and it's built on top of Tez. Now, when I started 9 months, 10 months ago, this is what Hadoop looked like. Hadoop 2 looks somewhat different. And it gives you the idea of the type of fluidity that we have in the architecture. New things come out, they find better ways of doing certain things, and the architecture changes quite rapidly over time. Now, first of all, when we started, as we said, we had the file system and we had MapReduce. Now we have MapReduce version 2, where they've taken out the resource negotiator out of MapReduce, put it into Yarn, and then found a better way of doing MapReduce queries, and they put it into Tez. You still have the ability to run your old MapReduce queries on top of Tez, but now Tez, what it is, it's a more customized, more optimal version of running your code. It runs on DAGs, for those of you who know direct oscillographs. I'm not even going to try to explain it. It's kind of outside my level of mathematical comprehension, but I'm pretty sure that some of you will be able to do a much better job at explaining to people what exactly a DAG is. Right, and then of course, on top of that, we have all the services, Pig, Hive, and the others that we're going to be talking about. And the final one there is we have Yarn, yet another resource negotiator. Takes away, or in this case, does the resource negotiator between my name nodes and my data nodes. So it knows where the information is stored. If I'm doing a query, I'm running it, I lose a node, it knows how to compensate for that, make sure that I get the correct data when I'm running my particular query. In a nutshell, that's kind of the core components of Hadoop. You can probably spend about 2 days talking about it. I have about 2 minutes. All right, so what we're going to be talking about next are the things running on top of Hadoop from a SQL Server perspective that, personally, I found quite interesting. And the first one I want to talk about is Hue. Because in essence, what Hue is the GUI interface on all those nasty things that we really don't want to do in the file system. So we don't want to go into the command line and we want to type stuff out. We want to interface with this in a GUI environment that is much more user-friendly. Now, Hue has certain flavors. Hue in itself is an open source project. And what basically happened is the different distributions, Hortonworks, Cloudera, MapR, they've taken Hue and they've customized it to basically fit around their offering. The example I have here is an example of the Hortonworks Hue environment. We've got very, very bad resolution, but we have all the little icons at the top. We've got Hive, Pig, HCatalog. We've got a file browser. All the different things that I want to do with my Hadoop system, I can do simply and easily via this GUI interface. The Cloudera one looks pretty much the same. Only difference in this one is Impala, which is a Cloudera-specific service running there, again, doing fast queries. I'm not going to dive into Impala. Quite happy to talk to you guys about it if you want afterwards. But to give you an idea of Hue, very simple, very straightforward, very easy to manage. Now, coming from a SQL Server environment, we're used to writing SQL queries. Now, that, in essence, is what Hive allows us to do. So in this scenario, what we have is it manages the data in HDFS, or at least it manages to read the data in HDFS using a language called HiveQual, and it's very, very SQL-like. In fact, if you look at an example of a particular query that you can run into Hive, what I've done is I've imported a flat file called New York Stocks. This particular example is part of the Hortonworks sandbox, so you can do this yourself if you wanted to. I've imported New York Stocks, and I've said select start from New York Stocks, where the stock symbol is IBM, the date is between date 1 and date 2, and I want to take the result and I want to order that by date ascending. If I didn't tell you I was running this into Hadoop, you'd swear I was running this directly into SQL Server. Very powerful, very knowledgeable. If you know how to write TSQL, you'll find Hive to be a very, very easy interface to get into. Good. The second one I want to talk about is HCatalog. Now, the reason why I particularly like HCatalog is it gives me a type of a schema that I have in SQL Server. We spoke earlier about the fact that we import our stuff into HDFS as flat files or text files. Hive, in this case, has a meter store, and HCat is built on top of that particular meter store, which kind of gives us our abstraction layer between our data and where it is actually stored. So what we have is we've got our products, Pig, MapReduce, Hive, etc., talking through HCatalog as a type of a schema to our underlying data. We don't care where the data is stored. We don't know what data types the data is stored in. The schema created by HCatalog tells us all of that. So it's very similar to having a view of your SQL data. You have a front end talking to your database. If anything in your database changes, your staging tables, you have to recode your front end. So what do? We create a view. Our code talks to our view talks to our staging tables changes, we don't have to recode our application, we simply repoint our view. Very, very similar in this case, HCatalog. And the nice thing is, again, it runs in Hue. So if we have a look at an example, not very clear, but basically this is kind of the interface that you have to set up a particular schema inside HCatalog. So that is the file I imported. I can specify delimiters, ignore white spaces, etc. But more importantly, it gives me columns of every single piece of data that it can find inside that particular file, and it allows me to specify a new name. It allows me to specify a data type. So now when I'm writing queries and I'm pointing Hive at my HCatalog rather than at HDFS, it knows what the data types are because I've defined a schema to use that. Pig. Right. Pig is a high-level platform to create MapReduce queries. We said before, MapReduce is pretty much Java, which is very, very great if you're a Java developer. It's very, very not great if you're not. So in this case, what Pig gives us is a programming language called Pig Latin. And what Pig Latin does, it basically takes our code that we write in Pig Latin, and it writes this optimized Java to execute as a MapReduce query on our Hadoop system. An example of this, I'm going to take the same table that I loaded my New York Stocks table, but this time I'm going to use my function, which I've created a schema in HCatalog, my HCatalog loader. I'm going to say, give me everything where the stock symbol is IBM, group them, and generate an answer with the average open stock price and the average closing stock price for IBM, and it's going to spit me out the result. Now, the language looks a little bit different from what we're used to, but if you're used to using Power Query, or in this case, M in Power Query, you'll see it's very, very similar. If you're comfortable writing M in Power Query, you'll probably have no problem picking up Pig Latin at all. So it's kind of the same debate that we had between VB.NET and C++. Do I write something in VB.NET? Do I write it in C++? Well, if you know C++, fantastic. If you don't want to learn C++, VB.NET is probably going to be easier to learn. Kind of the same concept. And we spoke a little bit about Hive being more structured. Fair enough. Pig allows you to go in and start working with custom formats, and it gives you a lot of flexibility in exactly how you consume that data. It's compatible with HCatalog, and it runs in Hue, which is fantastic. Scoop. Scoop really is the BCP of the HDFS. So if you want to take a bulk load, you want to do a bulk load from your relational database into HDFS, or you want to do a bulk load from HDFS into your relational database, you can simply use Scoop, and Scoop will give you the ability to do that. And it runs in Hue. My personal experience with this, I've had a little bit of trouble kind of setting this up and running it through Hue. Ended up dropping down to the command line and doing most of the configuration there myself. Maybe you'll have better luck. Maybe it's me. Oozie. Think of Oozie as your SQL Server agent of your particular HDFS or your Hadoop cluster. It helps you create workflows. It's a job coordinator, so you can go and you can set off and you can kick off jobs at certain points in time, or whether new data is available in that particular folder that you're looking for. So if you're used to using job automation, if you want to put together some workflows, Oozie is your guy. Scalable, reliable, and extendable. And again, you can set it up in Hue. So it's part of our particular GUI interface. Mahout. Slightly kind of off to one side. Mahout is something slightly different. It's a machine learning library. So if you're into things like recommendation engines, if you're Netflix and you go in and you've watched a couple of movies and you've rated them, they come back and say, you know what, you probably like the following movies as well, and it gives you a couple of additional options. So the way they do that is they take all of your data and all of the other people in Netflix, and they put it into one big data heap, and they tell Mahout, go and find patterns between what you liked and what other people liked. So in essence, what you end up with is you end up with, say, I gave movie A, B, and C a good rating. 10 other people gave movie A, B, and C a good rating, but they also like D, E, and F, so they're going to recommend D, E, and F to me. And that's kind of the type of recommendation that we can generate using Mahout. We've got clustering. So if we want to group documents and web pages together based on certain topics, or in this case, related documentation, this is quite relevant in the search engine side of things. We can do that using clustering in Mahout. And classifications. Think of classifications as almost like an email filter. So we know it's based on previous categorization. So if I get an email from Amazon.com, it's going to know that Amazon is a retailer, and based on the fact that Amazon is a retailer, it's probably going to put it in my spam folder. So these are the type of things that you can use when it comes to Mahout. And there are loads of others. I can probably spend about a day talking about these. Half of these I haven't used because, frankly, the way I approach this myself is I go and I look for exactly what it is I want to do. Google or Bing, whichever your search engine of choice is, what exactly these products do that can help you accomplish your goal, and then you find the appropriate one. If you're looking to stream Twitter information, Flume's a good one to use. Ambari, in this case, is a cluster management almost type thing. HBase, if you're looking for a type of a database implementation that's more read-write, random read-write, HBase is probably a good thing for you to use. Quite a few interesting other things to look at. However, more than likely the most important one that I want you to take away from this conference is the concept of Hadoop. Hadoop is the steaming pile of data you're going to want to store inside the elephant. And this is actually an industry-recognized term. So yes, I'm going to be talking about Hadoop quite a bit in the future, so definitely a good one to know. Good. So the next question is, who are the players? Who do I need to know about in the big data space? Typically, there are three big ones. We've got Hortonworks, we've got Cloudera, and we've got MapR. Now, slight differences between the three. Hortonworks, purely open source. A lot of the guys who started off with Hadoop and Yahoo kind of left, and they started the company Hortonworks. Everything they do is based on open source. They make their money off support for that, and not a bad distribution to get started on. Cloudera, very close to on their heels. Again, everything in Cloudera is open source, apart from one or two modules when it comes to cluster management as well as installation. But the rest of it, again, built on the complete open source platform. And then the third one there, MapR. What MapR has basically done is they said, fair enough, we've kind of looked at the whole HDFS system, and it doesn't seem to be very optimal. We're going to rewrite the entire thing to be more efficient. And that's exactly what they've done. They've created their own proprietary platform, and they build their Hadoop services on top of that. My opinion, if you want to get started with big data, Hortonworks is a fantastic place to start. They've got very, very good labs. They've got very good sandboxes. We'll talk about sandboxes in a little while. Personally, I think a great place to start. If you're going to start installing your own clusters, Cloudera has got a fantastic installation manager. In fact, it's probably the closest you're going to get to a enterprise window-ish type environment where you simply point it at a few nodes and you tell it to install, and it works really, really well. Unless it fails, in which case, unless you're a professional, you're going to have to start again from scratch. If you're interested in a benchmark between these, a company called Altros has done quite an extensive benchmarking test based on quite a few different scenarios about which of these are the fastest based on certain conditions. I've got the URL. You can download that for free. It makes for some very, very interesting reading. The slides will be up, so you guys can download this after the session. The one to watch for, cascading and lingual. Now, cascading and lingual is developed by a gentleman named Chris Wenzel and a couple of guys from a company called Concurrent Inc. What cascading basically is, it's a development platform that you build your applications on top of Hadoop. One of the biggest problems, and we actually discussed this in one of the earlier slides, was we said that 8, 9 months ago, it looked like this. Then 7 or 8 or 9 different components changed. The problem with that, putting it into an enterprise environment, is when you write code and everything changes, things tend to break. And trying to explain that to somebody who's just pumped a lot of money into this particular solution is a very uncomfortable conversation. So what these guys have basically done is they said, we're going to create a platform that fits on top of all of the distributions, or at least the 3 that we've mentioned. You write your code on top of the platform, and when anything changes underneath, they're going to take care of making sure that is compatible with their platform. So if things change, if new features get built in, it simply gets added to the platform, but the code you write on top of the platform stays the same. Slight caveat, it's Java. Unfortunately, there's no easy way of getting around that. Your platform, whatever you're going to design on top of this platform, is going to be Java, but it's definitely something interesting to look at. Some applications already existing on this particular platform is we have Lingual. So what Lingual basically is, it's a way of interacting with these data sources, again in an ANSI 92 SQL type state, using JDBC. So if you have a JDBC connector for any of your data sources, you can simply say, okay, I've got Oracle over here, I've got something in the HDFS, and I've got Redshift in the cloud. Select or insert into Redshift, select star from Oracle, join onto HDFS, enter, and it'll take that information and it'll put it into your destination source or your destination database. So very, very powerful. There's a reason I didn't mention SQL Server. We'll get to that in a second. Pattern, if you're doing any type of PMML, pattern matching languages, in this case machine learning algorithm, they have support for pattern. If you're a Scala developer, they've got Scalding. If you're a Clojure developer, they've got Cascalog. And then the jewel in their crown is Driven. Now, basically what Driven is, it helps you understand the data usage that you're pushing through the platform. So basically, it helps you accelerate and understand exactly what's happening to your data as you run the queries. We look at an example of Driven. It's kind of a visualized deployment flow. So think of it as almost a type of execution plan that you get in SQL Server Management Studio. You have all the different things going through the steps of transforming, loading the data from start to finish. And what this does, it breaks it up for you in a visual state, and then you can drill into each one of these, and you can see over there execution times, identify potential bottlenecks, look at resource usage. So a very, very nice way of evaluating exactly what's happening in your environment in a very nice GUI interface. Right, so why watch them? First of all, the 3 vendors we mentioned, Hortonworks, Cloudera, and MapR, they not only support this, but they actively invest in their particular platforms being supported by cascading. Why? There are quite a few big players using it already. Twitter, Airbnb, Razorfish. That doesn't look really good, but it's over there. Quite a few of the big players have already seen the fact that they don't want to manage all the changes in the underlying environment. They'd rather build on top of a platform that takes care of all of that for them on their behalf. It's a single platform for developing data. We spoke about that. They've also got something called single jar deployment. So you have a little cascading cluster running on your laptop. You write something, you test it, it works. You take the jar file, you pop it into production, you pop it into staging, you pop it into UAT, wherever, and it simply runs. If it runs on one of their platforms, it is, I won't say guaranteed, but it is supposed to run on every other app platform that they've pulled out. They've got the ANSI 92 version of Lingual that can help you maintain data, and most of their stuff, in fact, all of their stuff is based on open source. And a shameless plug for the company, we've actually been helping them co-develop their SQL Server plugin to plug into Lingual. It's still very, very much alpha stages. It does select star from table really, really well. It's kind of the other stuff that is struggling with. So we're kind of getting there. But if you're interested in getting into this, we have a blog that basically shows you how to get a Lingual cluster set up on your local laptop in one line of code. So it's definitely worth looking at. We'll talk about that a little bit later. So what exactly is the key differences between what we're currently doing in SQL Server and how we're going to be approaching this in the big data environment? Now, the next slide or two is going to be a bone of contention with a few people. So please do not throw fruit until right at the end, because this is a very, very simplified idea of how we construct BI architectures. There's a reason for me going through this in this fashion. So let's say, for example, we want to build a data warehouse. What are we going to do? Well, we're going to go and we're going to get the business requirements and we're going to prioritize them. We're going to find and collect all the relevant data sources, so we're going to figure out exactly where the data is that we want to use. Once we found that, we're going to normalize it, we're going to copy it into staging, we're going to create structures, we're going to create schemas, we're going to do the ETL. It's pretty much the meat and veg of creating your data warehouse. Once that's done, we're going to pull the data into our data warehouse, potentially create a cube, and then we're going to start answering the questions. Now, on the big data side, first of all, we'll get the business requirements and we prioritize. If we find a better way of doing that, you'll definitely make much more money than the rest of us. So we need to understand what the problem is. Once we understand what the problem is, the great thing about big data is we know where the data is. It's all in the corner somewhere. We've been dumping it for the last 2 or 3 years. We don't really have to go out and we need to find it. We know where it is. So what we'll do is we'll take one question, potentially the most important question that the business needs answered, and we'll create schemas and we'll ETL that question. So schema on read. That's the one thing. The reason why it's so easy for us to just chuck stuff into our particular data warehouse, or in this case, do our big data environment, is we don't care what it is when we put it in. We care what it is when we try to get it out. Once we know what the ETL process is or the schemas we've created, we don't need to copy the data to us. All the data is already spread across our 100 servers. We send the query to the servers, and the servers process this in parallel and bring the result back. I think probably the one feature that it can really tout is the fact that you don't have to bring it centrally. You send it out to where the data lives. You answer question 1, and then you restart with question 2. And that's kind of the methodology that we'd like to push. So what are the advantages and disadvantages of schema on read? We don't need to know anything about the data. We don't need to know what the data is. We simply point our user and say, go put it over there. We'll deal with it later. It's all available in a central place. And also, when we start processing this data, there's a high degree of parallelism because we're not pulling it into a central server. We're basically processing the data where it lives. And it's possible to start answering business questions quicker. So you might say, yes, but what if question 1, you needed all the data sources for that? Well, then yes, you're poked. But if question 1 only used 2 or 3 or 4 of the 10 data sources you require to build your data warehouse, potentially you can start answering questions quicker. So when the guy comes to you 6 months afterwards and go, where are my answers? You don't have to tell him his data's crap. You can at least give him one. Disadvantages, there's a new skill set. The company may not support the new technology. It's kind of hard. I tried to get some clusters built in the company I'm contracting for at the moment. They said no. And obviously, there are some issues with building schemas around data that might not be schema-friendly. But I think that's probably a problem that we have across most of the sources, including when we build stuff in the standard term. So how does this integrate with Windows and SQL Server? Well, through ODBC. Most of the vendors, Cloudera, Hortonworks, and MapR, they all have proprietary ODBC drivers that you simply load. Once the drivers are loaded, you can simply go and you can create a link server in SQL Server, and you can select the data directly out through one of your SQL queries. So you've got all this stuff in a Hive table, link server, ODBC, select star from local table, join onto a Hive table, you have your result. Integration services, if you already have data flows where you want to pull big data in, ODBC, pull it into your integration services package, it works. And then also one of the great ones, and you'll see this in the Hortonworks sandbox, if you want to simply have a user point his Excel queries at the big data environment. You can do that as well through ODBC. JDBC, if you've got certain applications that might rather use JDBC, you can point that directly to your big data query, your big data sources as well. ETL tools, there's a really nice tool we're going to talk about a little bit later called Talend. You can connect and you can manipulate data using Talend. And also, you can install it locally on your server if you wanted to. Hortonworks has something called the Hortonworks Data Platform that you can install locally on one of your Windows servers. Or Microsoft has something called the HD Insight Emulator. So if you're thinking of pushing something into the Microsoft cloud and doing something in big data there, you can download it, you can play with the emulator locally, and that'll probably give you what you need. Okay, so how do I get to ride the elephant? What are the tools I need to be aware of? And let's talk about a couple of places where I can get some inspiration. Well, first of all, if we're talking about where I can get some tools, if you want to run it locally, you can run it on hypervisor. There is some support for some of the sandboxes in hypervisor. You can run it if you're running Windows 8. You can run Hyper-V in Windows 8. VMware, if you've got VMware Server product, you can run it on VMware Server. Workstation, if you've got Windows, and Fusion, if you have Mac. Personally, I absolutely love VMware Workstation 10. It's kind of one of those things. I've been using hypervisor for all my life, and pre-Windows 8, you couldn't really run a hypervisor on Windows 7. So installing VMware on Windows 7 allows me to run hypervisor or at least Windows Server on my laptop without me having to dual boot into it locally and then phone up Dell support and tell them that I need a USB 3 driver for my Alienware PC running Windows Server 2012. Then they normally ask me if I'm a crackpot. All right, and then VirtualBox. VirtualBox is the Oracle free virtualization tool. The really nice thing about VirtualBox is it integrates very well natively with another tool we're going to talk about in a second called Vagrant. So keep that one in the back of your mind. If you have a laptop, 64-bit, 4 gigs of RAM, this is a really, really good potential virtualization tool. In the cloud, obviously, we have HD Insight, which is based on, as we said before, the Hortonworks data platform. I had some really, really bad experiences with HD Insight a couple of, 9 months ago when I started off, to the point where I actually told myself, I'm probably not going to be able to use this. I'm going to have to learn Linux. And that's kind of the way that I went. However, I went to a presentation at SQL Bits earlier, Real World Big Data, Adam Jorgensen and John Welsh, and they've really restored my faith in HD Insight being a potentially good place to do some Hadoop work. So yes, Microsoft started a little bit questionable, but looking at what these guys have done on Thursday, there seems to be some really, really good potential. For those of you who wasn't there for the session, you missed out big time. And then obviously we have Amazon Cloud. I'm not going to do a prop for Amazon. Right, Vagrant. This is probably one of the little gems that I found while trying to work with Linux clusters. What it basically is, it's a way of managing, maintaining, so spinning up, hibernating, and destroying complex development environments with a single line of code. What it basically does is if you want to spin up a cluster, you can create a cluster image and then spin it up from this configuration file. And through one line of code, you can then have your entire 4-node cluster up and running without you having to do anything. It supports VirtualBox, VMware, Docker, Hyper-V, and custom providers. And also a very nice thing about this is if you're using if you're using Vagrant and you've built an image and it works well locally, you can simply say Vagrant up on your image and point it to the cloud, and it'll spin up exactly the same image that you have locally into one of the Amazon hosting environments. Not quite there yet for Hyper-V, but I'm sure they're working on it. Talend. Now, I think the best way to describe Talend is integration services on steroids. Has anybody here used Talend? A couple of hands. This is a great piece of kit. Basically what it is, it's very similar to integration services. It gives you a lot of data sources you can connect to, you can do workflows, but the things that it supports is unbelievable. And also you can download a free version of this and you can play with it. There are two main versions. There's oh goodness. The one I'm using, which is the Big Data Studio, and there's another one that I cannot remember, but it basically has to do with data integration. And it gives you a couple of the advantages, a couple of things that it gives you. If we look at the Talend environment, very, very similar. We have our toolbox or our palette on the right-hand side. We have our version of the Solution Explorer on the left. and we have our workflows in the middle. And what we basically, the nice thing about Talend is it connects and it works with just about everything. Show you some of the data sources that it supports. You've got our relational databases there. We've got our Azure Blob Store. But you can use this thing to connect to just about anything out there. And if you're running Hadoop, you can use it to connect to it using Hive. You can run Scoop in it. You can run pig queries in it. And literally, it's such a welcoming environment that if you've used integration services before, it took me 5 minutes to get into Talend. You need to know a little bit about setting up certain objects. So if you're going to be talking to Hadoop, you need to know which ports to configure the components to. But once you've got that, this is very, very easy to use, and I can highly recommend it. Or you can potentially challenge your manager with a pet project and tell him that all those Dells that are sitting in the storeroom that nobody's using, you bet him that you can put together a cluster that will run faster than your development environment, and if he do, he'll give you a raise. He won't give you a raise, but at least if he gives you the time to do that, it's going to be an awesome exercise. So a couple of things you can do with big data. So a couple of sources of inspiration. Where can I go if I'm interested in getting involved in big data? Well, we spoke about the sandboxes. As mentioned before, both of the big three providers, Hortonworks, Cloudera, MapR, they all have sandboxes that you can download. Now, what a sandbox is, it's a pre-configured environment with all their services installed and working perfectly. It might sound silly, but trust me, to actually get your local environment to work as well as their sandbox environments is a very, very mean feat. So they've got everything configured. It's in a VM. You simply copy it to your system, you run it up, and you can go and you can play with all of the features, get familiar, potentially build proof of concepts in the sandbox. The Hortonworks one currently is on version 2.1, and it supports VirtualBox, VMware, and Hyper-V. So if you're running Windows 8.1, download the Hyper-V version, spin it up. It'll give you a URL to type into your browser. Once you've typed it in, it'll open up that Hue interface that we spoke about, and you can run. They've got tutorials to show you how to do just about everything. In fact, they have a tutorial, I think it's called Zero to Big Data in 60 Minutes. That's the first one that I did, and I was literally writing pig queries, writing Hive queries, and connecting my Excel to the Hadoop environment in less than 60 minutes. It is a fantastic place to start. Cloudera is currently on Cloudera version 5.0. I have no idea. They have a live one that you can try on the internet. So if you feel like doing some Cloudera playing around with, you can simply go. They've got a link on their website to go to a live implementation, puts it into Hue into one of your desktop environments, and you can play with it. Or you can download their sandbox locally. It's supported by VirtualBox, VMware, and Linux KVMs. MapR have their supported version for VirtualBox and VMware. And if you're interested in getting into cascading and lingual, you can download the Vagrant file from GitHub, and this is supported by VirtualBox. So again, as I mentioned, I've got a tutorial on our company blog to show you how to get an entire 4-node cluster up and running with a single line of code. Very cool. Good. Also, a source of inspiration is the Apache Software Foundation. Now, we said before that a lot of these components that you're currently using in big data came through Apache Software Foundation, but also they've got something called the incubator, incubator.apache.org. It's literally a crystal ball of telling you what are going to be the new big data things in the next 6 months to a year. Most of the projects coming through there, TES that we spoke about, Storm, Optique, Falcon, all of these are coming through the incubator before they reach actual top-level projects. So if you want to have an idea of exactly what the guys are planning to do, very, very good place to go and get an idea. GitHub, as not that much of a developer, I actually didn't really know that much about GitHub until I started searching for potential examples for big data code, and GitHub is an absolute treasure trove of just that. It's kind of it's a source control sharing open source mechanism for people to contribute to projects. It was created by our good friend, Mr. Torvalds, which gave us Linux. And if you're looking for any type of samples in the big data space, there's so many things out there. If you can think of something that you want to try, more than likely there's a project on GitHub that's already doing it that you can simply pull in and you can play with. So really, really good stuff. And if you're feeling very good, you might even contribute to some of these projects. All right, so what's the current and the future plans for big data? What are the current common use cases being used, and what are some of potentially the future opportunities in the big data space? Now, if you've talked or listened to anybody talking about big data, I think sentiment analysis is probably the first one that comes up. Sentiment analysis is kind of the thing that everybody's talking about because it's a quick win. You can go to the marketing department and say, you know what, how you can make more money by understanding your customer better, and they just light up and they throw money at you. That's sentiment analysis. So sentiment analysis, people typically go and they scrape some Twitter feeds, they scrape WordPress, they buy some Facebook likes, and they take all of that information and they try to figure out how do people feel about what they've done lately. In fact, that is normally coupled with natural language processing, which basically says, I'm going to take all those Twitter feeds, and I want to know whether or not what people are saying about my brand or about my company is positive or negative, and they're going to run it through some sort of a formula. An easy way to do it is just have two lists of words, bad words and good words, and do word counts. But if you really want to do it properly, that's the way to go. In fact, there's a really, really fantastic online demo where Stanford has actually opened up their natural language processing where you can go to the website and you can type it in, and it'll do an analysis on sentiment for what you've typed in. So you can't probably read it well there, but what it basically said is the new Iron Man movie was the best I have ever seen. Right, so it kind of gave a subtle blue on new because, new sounds good, but it gave a really big blue on best, because best is really a good word for potentially pushing sentiment. So all I really needed in there was a #IronMan3, and they would have absolutely loved this tweet. But this is typically what they're talking about when they're talking about sentiment analysis. Recommendation engines, we spoke about recommendation engines. We want people to buy more, whether or not you're Amazon, whether or not you're Netflix. Recommendation engines are pretty much a good way to go. And then anti-money laundering, know your client, the type of stuff that the banks do. I cannot understand why this is not being used. If you read any type of book on big data implementations, and they talk about case studies, the first thing they say is anti-money laundering. Because you know what, we can specify, we can define patterns, we can then figure out if this is how people launder money. We simply just need to monitor those transactions, and when we see that pattern, we raise a red flag and we stop that. Funnily enough, I had a conversation with the director of one of the big 4 consultancies around security, and I asked him, why are you guys not using big data for your anti-money laundering projects? And he said, and I kid you not, he said that I don't think big data can handle the volumes that we're pushing through. I mean, we're talking about like thousands of requests a minute. I'm like, really? Have you heard of this thing called Twitter? And he goes, yeah, but I don't think that'll work for us. And I thought, you know what, I'm going to stop talking now, because what I'm going to say next is more than likely going to be a career-limiting move. So I got out of that conversation really quickly. I don't understand what the hesitation is, but this is definitely a good way to go. So what are potentially some of the future opportunities of big data? Well, sensors. Not very sexy, but definitely some potential there. I mean, we have sensors that do temperature, pressure, gas, smoke, and these things generate a lot of data. Now, if you can use the sensor data to potentially predict when a particular piece of machinery is going to fail, or when a particular stock level is going to run out, or anything like that where you can potentially prevent any downtime for a particular system, that is worth a lot of money to companies. Because once it breaks, you have to wait for it to be fixed. They can potentially lose a lot of money. What about self-contained clusters? Went to the Hadoop Summit in Amsterdam and met these guys from Big Boards. This is a fantastic piece of kit. What they basically do is they build little Hadoop clusters. And this one, 5 data processing nodes, 20 CPU cores, 5 terabytes of core storage, and a gigabit Ethernet adapter. And isn't that cute? And it all fits into that little box. And you're thinking, wow, you know what, fair enough. Potentially, a lot of the places where I want to go and I want to do big data crunching is not very laptop friendly. So why don't I put one of those in there? So if we think about potential, let's say we'll take one of those plus a few sensors and we'll stick it on one of those. And when we do, we can monitor pressure, we can monitor any other things that we might want to monitor to potentially stop one of those, or one of those, or one of those. It's worth a lot of money for people, not to mention the environment. I have to mention the environment. Or you take one of those and you put it on one of those. So now you're taking temperature of the sea and you're measuring seismic activity, and all of a sudden we have an early warning system that could potentially warn people against one of those. And if you're sitting in the back and you can't see, that's a really big wave. Right. So there's definitely some potential here. or take one of those and put it into a mine. I'm pretty sure there's some really hectic stuff that can go wrong in a mine. I have absolutely no idea, but potentially yes. If it could potentially save people's lives or production doesn't go down, there's some really, really good potential for taking this data, understanding it, and then making the appropriate adjustments. Now, what's the summary of what we're talking about? Now, typically in this case, big data is not there to replace SQL Server. It's not going to replace the random read, random write reporting capabilities we have in SQL Server. It's not even close. It's not going to replace our trusted high-volume, transaction-safe OLTP frameworks that we've been working on for years. We've been with relational databases for, 30 years now. This technology is only a couple of years old. They're still going through all the growing pains that we had with relational databases. What it does give us, though, is it gives us opportunities for storing and processing vast amount of data that previously just wasn't really feasible in our relational database environment. So the conclusion here is, personally, and this is my personal opinion, I don't think the future is going to be won by one technology or the other, but more than likely by a combination of the both. And that's what I think, my 5 cents. Any questions? We have 11 minutes. Nothing. Wow, anybody still awake out there? Yes?
What sectors in the UK are really using Hadoop?
From what we can see, very few, which is a little bit disconcerting. Most of the stuff that you see happening is around sentiment. So, but the banks seems to be a little bit worried about Hadoop because, first of all, a lot of the stuff runs on Linux. They don't really want to use cloud solutions because they don't want to take their data away, but they also don't have the local manpower to actually go and build a solution on top of this. So everybody's kind of sitting back and watching and seeing who's going to do it first. And I think whoever gets to the mark first, more companies are more than likely going to follow. Yes? Oh, sorry. I wouldn't say it's better. I think it's not a bad option. Cassandra is a great way of dealing with that, but I think there's probably 4 or 5 ways of skinning a cat. Yes, there are definitely more ways of skinning a cat. So absolutely, this is not the silver bullet. And I think that's the other thing. Whenever people talk about big data, they talk about this wonderful silver bullet that's going to solve all of our data issues. And it's just not the case. It's when we had CLR built into SQL Server 2005, and everybody said, wow, we're going to write all of our code in CLR. No, you're not. If you're doing data manipulation, T-SQL is going to beat CLR hands down. And I think it's kind of the same type of scenario. Yes?
What's the scale at which Hadoop is currently a better solution?
The question is, what's the scale at which Hadoop is currently a better solution? When you're doing a petabyte data sort in 16 hours and 16 and a quarter hour. I think it depends from situation to situation. If you have, I think the sensor one is a good idea. When you have multiple sensors generating gigabytes of data every hour, you can potentially use something like Flume. Flume, by the way, is the Twitter streaming application that allows you to stream data, real-time data, into your big data cloud and then potentially do some calculations on that. Now, you could put that stuff into your relational database and do some computations or use what's the in-stream function that we have in SQL Server? Wow, this is embarrassing. That does kind of does the aggregation as you stream information through. Properly, you can use that as well. I think it's not one or the other. I think there are options for both. No further questions? All the tools that I've spoken about is on the slides, so please feel free to download the slides. All the tools are there. All the sources that I have pillaged for information for my particular slide decks there as well, if you want to do some more reading. And thank you very much for coming. The copies of the slides will be available on the website. I'm sure the guys at SQL Bits will make them available as well. All the contact information is there. Please feel free to come talk to me afterwards, and please remember to do the feedback online. Thank you very much.